Hello. Today we're going to continue Topic 2, Section 5 and Section 6, talking about modeling functions. And this lesson is all about cubic functions, which is the more specific type of polynomial functions. Okay, so to understand cubic, we should basically know what a polynomial function does. So let's start there. A polynomial, right, in case we forgot, is you just have all your x's. You can have 1 or 100, it doesn't matter, but all the x's have degrees, right, that are integers. I'm sorry, more specific, whole numbers, positive whole numbers. So like 1, 2, 3, 4, okay? So we have x squared, x to the fifth, x to the millionth, okay? You will not see, okay, a polynomial function cannot have x to a negative number, right? So that means it can't have 1 over x or anything like that, all right? It also can't have, remember I said whole numbers, so it can't have integers, or, that's silly. You can't have fractions or decimals, that's what I meant. So you can't have x to the 1/2, all right? So we think about these functions, okay? So a would be a function, because if we were to FOIL that out, you would end up with 2 times 3 is 6x to the 4th plus 8x cubed, so that is a polynomial. For b, I would distribute that, so you would end up with negative x to the 4th plus 2x. That is a polynomial, all right? But part C, that is not, because what's another way of writing the square root of x? That's just 5 times x to the 1/2 plus 2. All right, so that is not a polynomial function. So only A and B. Okay? All right, now to break it into 2 parts, you can have either even powers or, of course, odd. So let's start with the even powers. All right, so an even power would probably be, I guess the most common one you've probably seen is you can have 3x squared plus 5x minus 19. All right, we have x squared. Okay, we can have f of x to the x to the 100th. Okay, that's a polynomial, and the degree is even because the highest exponent is 100. So even if I had plus x to the 99th, okay, it's still even because 100 is even. Okay, so what this part, okay, what all this is doing is saying that what the end behavior is doing. Okay, so let's think about the most basic one we have. Okay, think about f of x equals x squared. So hopefully you remember that as doing this. Okay, so x squared is a positive parabola. So as, here, let me put my x and y axis on here, so we can look at the end behavior, not what the middle part's doing, but what the arrows are doing. So the first thing we look at is we look at our x. So x is along this line, or x-axis, towards negative infinity and positive infinity. So let's talk about this one first. As x is going towards infinity, so as we go along this, all right, what is happening to our y? And our y is along this axis, where this is y going towards negative infinity and y towards positive infinity. So as we go up that arrow, as x is going towards infinity, the y is going towards infinity. And that's what this is saying. As x is going towards infinity, f of x is going towards infinity. So as x is going bigger, y is getting bigger. Now, the left side, okay, as x is going towards negative infinity. So now as we go, let's see, I'm just using all the colors. Okay, so as we go this way, all right, as x is going to be negative, if my y is increasing. And so that's why we have, what am I doing? I'm trying to put plus or minus, not infinity over a negative. Silly me. Okay, let me write this nicer. And that's why it's saying as x is going towards positive infinity, also the negative is doing the same thing. Both ends are going up. Okay? So, the left side and the right side are both going towards positive infinity. Every even power will do that, even f of x. F of x to the 100. Okay? Now, that's not the only parabola you've ever seen. You've also seen a parabola that goes down. Okay? So, why would it cause my y's to go down? Well, hopefully you know that is just from a negative x squared. So when you have a negative in front of your coefficient of your highest degree. Okay? So that just flips our ideas. Well, not the y. I'm sorry, not the x, the y. So if my parabola is going down, then I would say as x goes towards positive or negative infinity, my y will also, on both sides, will go towards negative infinity. So as x is increasing, y is decreasing. As x is decreasing, y is decreasing. Okay, so that's for a negative ax to an even power. And this one was a positive ax to an even power. Okay? Okay, so now these are your basic rules here for an even. All right, now we can do an odd power. So an odd power is when you have f of x equals x to the 99th minus x to the 86th plus 4x squared plus 28. All right, that's still an odd power because the highest degree is 99. Probably the most common odd power you've ever seen is the very first function you learned, which was f of x equals x, right? mx plus b, a line. Think of it like that. That's the most common. So think about what happens with your line. You can either have a positive line or a negative line. So this is when f of x is a positive a value, x to some odd power, right? Because all odds are going to follow the same pattern. And this is when f of x equals a negative times x to an odd power. Okay, now again, I'm still only talking about the ends of my graph. I don't really care what happens in this middle section. All right, that's what I'm talking about. Odd functions are going to do something like this, and like this. Like it could do a whole bunch of weird stuff in the middle. Okay, so I'm not looking at the middle, I'm looking at the ends of my graph. So that's why it's easier to visualize just a line, right? Something we're used to graphing. All right, so now let's put it in the proper notation. So again, I would visualize your x and y axis. Okay, now on this side over here, as x is going towards infinity, the arrow is going up towards infinity. So as x is going towards infinity, then f of x, the y, is going towards infinity. But if we look at the decreasing towards negative infinity, So this is x. We're going to look at our y is also decreasing. So here we're going to have to write it and as x is going towards negative infinity, then y is going towards negative infinity. Okay? I would not sit here and memorize which one each does for odds and evens. I would think about lines or parabolas and then visualize the ends and go, okay, as x is getting bigger, y is getting bigger, then write it. All right? I really think that would be very complicated to sit there and memorize all that stuff. Okay? So the proper notation for this one, okay, oh, that's a terrible arrow. My goodness, my pen stopped working, sorry. Okay, so for this one, as x is getting larger, then f of x is getting smaller. And as x is going towards negative infinity, y is going towards positive infinity. So x is getting smaller, y is getting larger because we're over here. Okay, so that's how you can tell the end behavior of your functions. Now, we are going to be a little bit more specific. We're going to talk about cubic functions. So that's when you have ax cubed. Now, what I would, of course, do is always use your graphing calculator. You've got it, use it, okay? The things that are going to be important when I ask you to sketch is to draw and label and scale the axes, show the coordinates of the x and y intercepts, and show the max and mins, okay? So let's do one together. So here's example 3. So I'd go into your calculator, I would type in the equation, let's see, x cubed, then plus 2x squared minus 5x minus 3. To make sure my graph is kind of standard, I'm going to do zoom standard, so press zoom and then 6. And it's taken a while. There we go. So now I can visualize what my graph is doing. So now I want to be able to find the x and y intercepts and your min and max. So I'm going to show you how to do it with the calculator. So to double check ourselves, I'm going to go ahead and show you the answer and see if we can get those same things on our calculator. Alright, so you go to second trace, and here you can find a lot of helpful tricks. Okay, so let's start with our value. Okay, our y-intercept. That's the easiest one because when we're looking for our y-intercept, x just has to be 0. So we're going to trace it for x is 0. So at 0, our answer is negative 3. So that's our y-intercept. That's how we got that one. So y-intercept. So make x equal 0. Now let's find the x-intercepts. So do second trace. And I'm going to find the zeros. That's another word for the x-intercept. So you follow your commands. It says left bound. So I'm going to find this middle one here. So that's on the left side of that point. And then I'm going to find the right side. And then I'm going to guess the point. Close enough. Okay, so now we found negative 0.52. Watch that negative sign. It's very easy to miss. And the decimal. And notice the y is 0. And perfect. Okay, and I can do that for the other 2 points. Again, it's also a polynomial. Use your simulation app. So set that equal to 0 and use my that simulation app to solve it. Okay, that's what's great about that. So hopefully you have that app. Okay, let's see. Then to find our max and mins, we do second trace. select minimum or maximum. So let's start with our minimums. That's this one down here. Follow your commands. Find a point left of the point. Find a point right. And then guess. And there's our minimum, 0.79 and negative 5.21. Okay. So that's how you want to find them in your trace function. So I'm going to write them out. So these are your zeros, and this one was your maximum, and this one was your minimum. Okay, so use your calculator to find those, and then you can plot them just like this. Alright, so this is a very common problem. I've seen this a lot through Cognity in just the short time I've been through it. So here we have a box, and we're going to cut out the corners and then fold them up. So what I mean is we're going to fold them along this dotted line, and that's what's going to cause us to make a box. Okay, because this point and this point are those edges are going to meet, and you can glue them together, and that's the corner of your box. Okay, so that becomes that. Right, I hope you can visualize that. Alright, so here it says explain why the length of the box is 30 minus 2x. Well, the length isn't 30 anymore. It's now this. Well, this part is just the whole thing minus these little sections. So 30 minus 2x is right there. Okay, because we're removing 2 corners of that side. And we can do the same for the width. So the width is now here. So we're taking 15 and subtracting our corners. Okay, so that's why. Okay, you're removing the corners. Alright, so that's how I'd probably write it. 2 corners are removed from each side, because that's what it is. It's the length minus 2 of the corners. Okay, so find a model function for the volume of the box in terms of its height. Okay, so what we do to find the volume of a box is you do length times width times height. So we just discovered that our length was 30 minus 2x. We found our width was 15 minus 2x, right? And then our height of our box is just these edges folded up, right? So our height is just x. All right, so that is what x represents. So this is our volume. This is our formula. Our formula would be this, and we can actually factor it out and write it as a polynomial if we wanted. Okay, so when you FOIL all that mess out, you get this polynomial, 4x cubed minus 90x squared plus 450x. Now, if we wanted to write it as a function, right, in that fancy form, you could say the volume of h, because remember x just represents the height, 4x cubed minus 90, why am I putting an x? I just changed it to an h. Okay, I'm only showing you this because this is typically how they write their functions. It's the same idea, only you wrote it with an x, and that's perfectly fine. I will take that as an answer. Okay, I just want you to understand that this is the same idea when they put functions in this form. Okay, it's the same idea of what you just found here. So find the values of x for which your model is meaningful. Okay, so we want it so that the height is, let's see, greater than 0, right? We don't want a negative height. So let's see, we also need our volume to be, we need our length to be positive and our width to be positive. We need all these things to be positive. So what we need is to write each one of these must be greater than 0. All right, and we can solve each one of these. So we get 3 inequalities. All right, so here for this one, we get x must be less than 15 for, that's going to be too many arrows. Okay, you know what I mean. All right, so then this one is going to be x is less than 7.5. And this one, x has to be greater than 0, right? You don't have to change that one. So here, if we were to graph all of those, where all of those make sense, okay, we need all to work. So we can visualize it, okay, so 7.5, 15, and 0. So we want to be bigger than 0, less than that, and less than that. The only part where all 3 of those arrows overlap is right here. And we don't want it to actually be any of those. So that's why they write the inequality. Your answer that's useful would be that x has to be between 0 and 7.5. Okay, you can write it as an inequality or as an interval. That's fine by me. You write it as an interval, you can put parentheses, 0, 7.5 parentheses. No, that's not a point. That's in the values. It's an interval. Okay, I'm fine with that. So then we're going to plot the graph of the volume function. So we get out our calculator, and let's see, we want to do 4x cubed. I just insert 4, then minus 90x squared plus 450x and no minus 3. And I'm going to change my window because I don't anticipate, well, I want my x to be between 0 and 7.5. Anything after that is useless. So I'm going to put 0, and my maximum, I'm just going to do 8 just to make sure. All right, go a little over. And then I'm going to do my minimum and maximum. I mean, here you really just got to kind of play with it. Okay. I can already tell, though, when I plug in 1, I'm going to get a pretty large number. Okay. So let's see. I'm going to just try 500. And let's scale it by 100, so that way I don't see a whole bunch of tick marks. Okay. Oh, that's a maximum. Silly me. Might help if I actually put these in the right spot. So let's do the minimum is 0, right? Because I don't want my volume to be anything smaller than that. So if we graph it, ooh, you see my stat plot. Sorry, ignore those dots. That's from something else. All right, but now you can see I've got my volume going. It's like a parabola. All right, in this part, I'm missing some, so I need to go a little bit higher. And I'm going to turn off my stat plots. Second stat. Go over, turn that off. What was I doing? Oh, changing my window. Oh, silly me. Yep, change the window. Okay, so let's just go up to, I don't know, let's do 750. Am I high enough? Yes. There you go. Okay, so that's your graph. All right, and then I would find your intercepts. Okay, go ahead and find those, and then your maximum. So if you plot the maximum, you should get, the maximum point is 3.17, 650. okay? And this helps us find the dimensions, right? Because this represents our x, right, based on what we had up here, and this represents our volume. So the maximum volume we can get with this box, with a 30 centimeter by 15 centimeter box, is 650 cubic centimeters, where the height is 3.17. And then I could even plug it in to find length and width, okay? If it asked for it. It didn't ask for it. Oh, actually, I'm sorry. It said interpret its coordinates. All right, so here it says that x is 3.17, so that means the height is 3.17 centimeters. The volume, okay, the max volume, actually, because we found the maximum, is 650 cubic centimeters. When we take this x value, 3.17, and we plug it into 30 minus 2x, that gets us our length. And our length is 23.66 centimeters. And then when we plug it into 15 minus 2x, that'll tell us our width, and that's 8.66 centimeters. Right, and that's how we can interpret it. Okay, so now we've got another word problem, and the takeaway here, okay, pause it, read it, right? All right, so the takeaway here is that the height has to be 5 times larger than the radius. So if the radius is r, all right, then the height is going to be 5 times it, so 5r. So find the volume, or I'm sorry, find the formula that describes the volume of the container as a function of the radius. So that means we don't want to use h, we want to use 5r. Okay, that's what's important here. Now you want to know what the volume is, so hopefully you remember this from geometry. Any straight, how do I word this, perpendicular to the ground, right, straight up, standing straight, standing tall item, you can find the volume of any item like that by doing the area of the base times the height. So we think about the base of our can. It's a circle. Yes, it's the cylinder, but that's a circle base. So our base, so let me put this up here. I guess I should say area base. So our area of our base is going to be pi r squared, and our height is 5r. So our formula for the volume is 5 pi r cubed. So now we want to find the volume when the radius is 3. So we just got to plug that in. So 5 times pi times 3 cubed. We plug that into our calculator, and we should get, what is that, 424 centimeters cubed. Sorry, I guess I should show you. In case you don't know where the pi symbol is, you can do 5 times, the pi is above the caret symbol, so you do second caret, and the pi pops up, times 3 cubed, or just 27, is 424. So to 3 sig figs, it's 424. And the last one is asking us if the volume is 400, explain why 80 equals pi r cubed. All right. All right, well, since the volume is 400, we can just say 400, because our volume is 5 pi r cubed. Well, we want the pi r cubed alone, so just get this alone. So let's get rid of this 5, so divide it out, and we get 80 equals pi r cubed. And there we have it. Okay, so the last problem I'm going to do for you guys is show you how to plot it. Okay, so here we're going to draw a scatter plot. So we go to our stat, edit, we put it in our list, we go to our stat plot. Second y equals. We're going to turn our stat plot on. Scatter plot, list 1 is my x's, list 2 is my y's. Okay, my speed, and then the average boat speed is y. So I'm going to go ahead and get rid of this equation so it doesn't pop up, and I'm going to do zoom stat. And here I've got my all my data set, or my data values. So I want to figure out if a cubic function fits that data. Right, so that's what we do next. So we go to our main screen. I'm just going to go back here. Then we go to stat calc, scroll down to, pressed it too many times, 6 cubic regression. Let's see if that's going to fit. List 1, list 2, looks good. So we calculated it, and now we have our A, B, and C, and D. So all of our coefficients for a cubic function. Okay, so now we're going to use our model to estimate the average speed. So then I'm going to write out my equation. So here's my equation all written out, and you can see that these are my A value is in front of the x cubed, my B is in front of the x squared, C is in front of the x, D is all alone. Okay, and then there I want to use this model, that's for the equation, use this to find the average speed of the boat for an engine speed of 2,500. So you're writing this as RPMs. So make sure you're plugging that in correctly, because now we want to make sure x is 25, because it's hundreds of RPM, so 2,500. So we plug x into our equation. You can plug that in and get y equals 24.5. So 24.5 knots. All right, so that's it for cubic functions.